Yeah. What? Yeah. Yeah, it's going to be pointers and nothing but pointers for the till the end of time. Dang it. There's a water fountain just down the hallway, my friend. Yeah. So, okay, so let's just do one quick little thing on the pointer department that I think hopefully will make things a little bit clearer. So I think one of the things you guys are bothered by is something like this, right? Why the asterisk there? Okay, so what is this doing, this instruction? Yeah. Yeah, it's declaring a pointer named myPointer, okay? And the reason that we have int and the star is because what we're doing is saying not what thing does the pointer point to yet, we haven't said that, but what kind of thing is the pointer pointing to in this case? An int, okay? And so star myPointer, the thing that this pointer is pointing to, is of type integer. Now, we haven't specified what integer it's pointing to. Okay, so in that sense, my pointer is as right now uninitialized, okay, because does it actually point to a specific integer out there? Not yet, right? We could declare such a thing, right? So I could say, for example, int x equals 5, and then do something like my pointer equals ampersand x, okay? And after these two instructions, okay, x is now something that's in memory somewhere, okay, with the value 5, and my pointer, I've now updated it to actually point to that object, okay? And then if here, like, let's say that I had, so what would happen if I did something like this? Probably wouldn't work, but why? Yeah, I said that my pointer is pointing to an int, but then down here I'm trying to make it point at a float, and those are two different data types. Okay, so I mean, let's just see what the compiler does here, just for sake of demonstration. Right, it's going to give us a warning, not a full-blown error, okay, because we've kind of done a mismatch here on the data type, okay? And let's just do, for example, a print statement so we can see right. Oh, and by the way, I think this was a few times ago, I put in %f, and when we were printing a single precision float, and then I was like, oh crap, what is it when we want to print a double precision float? It's actually %f. Same thing. Okay, but there's actually a better explanation for that, which is on this system, printf only accepts 64-bit floats. So what you have to do, and we'll see this in assembly, if you want to print a 32-bit float, you first have to convert it to a 64-bit double and then print it. Okay, so we'll see that in just a second. Yes. Right, double is a 64-bit float. Float is a 32-bit float. Yeah, so double means double precision. A 32-bit double is a contradiction, right? A double is a 64-bit object. It's a 64-bit floating point number, right? And a float is a 32-bit floating point number, okay? And then there is a half precision floating point standard that's 16 bits. And then there's another version called B float, which is a half precision 16-bit, but it's defined a little bit differently. And that one is used a lot in machine learning contexts, so GPU programming type stuff. Yeah. So yeah, if you use doubles all the time, then great. And on the ARM architecture, the floating point hardware is capable of natively working with really any of those formats. Okay, but if we were to go back a number of years, right, to the 80s or whatever, the first floating point hardware did it with 32-bit, or at least that's how the stuff was stored, was with 32 bits. Um, and but then in terms of its internally, like the first Intel coprocessor for math, internally used 80 bits for extra precision, and then it would sort of truncate off when it reported out an answer. But yeah, um, yeah. Okay. So anyway, it looks to us in C like we're cheating, right? That there's no difference between printing a double and a single precision float. But what's going to actually happen here is if we look at the assembly for this, we would actually see that before it does this, it's going to convert this float to a double. Okay, now it still would have the same value, right? If you go from a single precision float to a double precision float, do you lose any precision? No, you in fact gain precision, right? The other direction, though, you could lose precision, right? So going from 32-bit to 64-bit perfectly preserves your precision. It's the other direction that you have a problem. Okay, so let's say we did something like this is 0x, and then what do I need here? Okay, li, because the pointer is a 64-bit thing, right? It's an integer. Oh, sorry, lx, because I want it in hex. Okay, and let's do a carriage return, and oh, what else do we need to pass this thing? Yeah, we need to pass it the number y, and we also need to pass it what? Here, let me widen this a little bit. Yeah, we got to pass it the pointer. Okay. All right, so let's just scooch this a little bit. I do, right, which is why the compiler threw this warning at us, right? Because I'm saying that the my pointer is pointing to an int, right? So this says it's pointing to an int, not that it is an int. Okay, does that kind of make sense? Yeah. And then here I'm being silly and pointing it at a float, okay, which it's gonna yell at me for that. It's a warning, not an error. So we're gonna see what happens if we run this, right? So it works, okay. And why did this work? Even though we got thrown this warning. Well, because what is a pointer? really. Yeah, it's just a memory location. And I can find out the memory location of any object I want. Okay, so when I did my pointer equals ampersand y, the ampersand y part is saying, okay, what's the address of the floating point number y? Well, it is whatever it is. Okay, um, and that address is a 64-bit integer because what are memory addresses in this architecture? What's the memory address on the ARM AR64? What's the memory bus? 64 bits, right? That's why it's called AR64. Um, okay, so that means that all of my addresses, all of my pointers are really just 64-bit numbers pointing to some memory address out there someplace, okay? Um, and so doing my pointer equals ampersand y and saying that I'm going to assign an int, a pointer that previously was pointing to an int to now point to a float is naughty, okay, in the eyes of the C compiler, but it'll do it, right? Now, when we get into assembly, there will be no such protection because there is no compiler, right? There's an assembler that's going to translate your assembly into the machine instructions, but that's it. So here, what we've seen is that the compiler is being nice and trying to catch our screw up, okay? But yeah, okay. So on the subject then of this floating point thing, let's actually do um, let's compile to assembly. Okay, still going to complain about that. And then let's look at our assembly for right before we hit the print. Okay, so right here. Oh, it's Socath, his eyes uncovered, right? Do you guys get that reference? Socath, his eyes uncovered. Shaka when the walls fell. It's from Star Trek. Right. It's from the Next Generation, season 5, episode 2, I think. Darmok, one of the pinnacles of television. So it's Darmok and Jalad at Tanagra. You guys have no idea what I'm talking about. Yeah, you get out. For EQ, you mean? Yeah. The Measure of a Man. Who do you think made that happen? This guy, yeah. Yeah, okay, so what's the difference between star and ampersand? Well, help them out, guys. So you use the ampersand if you're working with a variable. So ampersand variable, so if I just typed y, it would mean 3.5. Ampersand y means whatever the location of y is, okay? The asterisk means whatever is at that memory location, okay? So if I were a dumbass and did star ampersand y, okay, what would that mean? What does ampersand y mean? So y is a number. It's out in memory somewhere, okay? What does ampersand y mean? The location of that number, okay? And what does star of an address mean? What's at that address, okay? So like I said, if I were being silly and said star ampersand y, I would say, oh, okay, I've got y, it's a number. What's its address? And what, they basically cancel out, yeah, okay? I'd be asking, what is the thing at the address of the pointer, which is just y in this case, okay? So I wouldn't actually do that, star ampersand y, because that's sort of redundant. I could just say y, okay? Um, but maybe if I needed to do some arithmetic or scan through an array or something, I might want to do star and then have an address that I've modified somehow. So like, for example, I could do star ampersand y plus 1 to say, okay, y is at some memory address. I want to know what's at the next valid memory address and see what's there. Okay, so there that wouldn't be silly, but yeah. Connor, question? Okay. All right, so does this kind of make sense? We? Yes, is whatever the address of the object is. Yeah, so asterisk of a thing reports to you what is at that thing uh, interpreted as a memory address. Ampersand of a thing says, okay, that thing is out in memory somewhere. Where is it? Okay, so to go back to our mailbox analogy, asterisk thing asks, what is inside the mailbox? Ampersand thing says, that letter was in a mailbox. What was the number on the door of the mailbox? Okay, does that kind of make sense? Yeah? Okay. It'll sink in. So, I promised you guys hopefully a better explanation. Maybe this cuts it. So, what's the source for this? Well, when in doubt, go straight to the horse. Okay? Because who are Brian Kernighan and Dennis Ritchie? Huh? These are the guys who created the C language in the first place. Okay, so you can't, I mean, short of like going and finding wherever they are, and dragging them in here and tying them to a chair and say, "Splain yourself." Uh, this is about as good as we're going to get. Okay. Yeah. And actually, you know, it's funny because this was a lot smaller of a book than I was expecting when I got over to the library. I was expecting some massive tome with like illuminated manuscripts and, you know, singing angels when I pulled it off the shelf. But uh, yeah, it was not so. Instead, when I pulled it off the shelf, I had to listen to Rippy asking me what I was doing. So, anyway, huh? No, I should have, right? No, he just so happened to be up on the third floor right when I was pulling this book out. And, you know, all of Greencastle knew he was on the third floor of the library, but yeah. Oh, Rippy. So, all right. Well, so back to it then. The point I wanted to make about the floating point printing is that the C compiler has basically said, oh, right, to use printing with floats, I can only really print a double. And so what it's done is it's taken my, so the line I've got highlighted there has taken something that's in a single precision register, hence the name S0, and converted it to a double precision thing in a D register, and then printed it. So everything's good. Okay, so we'll talk about all the registers and all that stuff later, but um, uh, you never actually print a 32-bit float. What you're really doing is printing a 64-bit copy of it. Okay, does that make sense? And this is why then there's no separate um, there's no separate um, formatting character, format string thing for the different floating point standards because you're using sort of the highest precision floating point standard available on the machine, which for us happens to be 64-bit. Okay, good. All right, so there that answers that, and I should have remembered that from last year, but it's been a while, so c'est la vie. Okay, good. So let's. The last thing I wanted to talk about in C before we move on to the assembly stuff are sort of compound objects, which, what would you call these things in Java? or Python or whatever. Yeah, you'd make a class or something along those lines, right? So if I wanted to have, for example, so what data types? So let me make a new file while we're at this. What data types do I have at my disposal in C? Right? What are the basic data types? Hmm? Yeah, the basic data types that we have available to us. Okay, we have integers, we have long integers, which are the 64-bit versions. Okay, we have characters, which are kind of basically 8-bit things. What else? We have, okay, strings really are not a single data object, right? What are strings really? They're an array of characters, okay? But that's a construct that we use so frequently that we kind of pretend that they're a single object on their own, okay? Um, but really, they're an array of characters, okay? Good. All right, so characters, integers, long integers, which are double precision, or I mean 64 bits, so they're better precision. We've certainly also got floats and doubles, right, for the floating point side of things. Am I missing anything? We've got pointers, right, which are really just sort of a special flavor of integer. Um, from the C and the compiler perspective, there's a difference between a pointer and a 64-bit int. But in terms of like hardware, is there really any difference? No. Okay, they're just numbers. Um, and the C compiler is being nice because when you compile this, what is it doing? It's doing a bunch of lexical analysis on your code, and it's smart and catches things like our pointer mismatch here. Okay, assembly's not going to do that for you. You have to be smarter than the machine, which I know is going to be a real challenge for some of you. Okay, um, Mr. Powell.
You just insult our president.
Huh?
You just insult our president.
I did. Right.
Take away some gentleman coin from him.
Well.
He is the secretary.
Huh? Yeah. Well. Okay. So Mr. Powell has this ability. Right? Mr. Powell could do that to take away one gentleman coin. And he just did? Well, see, I have a power that, sorry, I have this power. Who's more powerful, do you think?
Gentleman coin.
Huh? Yeah, but see, gentleman coin is like Bitcoin. It's not even a currency. What is it that Dr. Dunaway calls it? It's a fiat commodity, and its value, intrinsic value, is nothing, right? Uh, well, no, that's not to me. That would be an extrinsic value. Its intrinsic value is what it's worth just on its own, right? Without human sort of involvement. Okay. And right now, the gentleman coin cannot be redeemed for anything directly. Can I go to B Dubs and get a whole bunch of boneless chicken wings with my gentleman coin? Not yet. Huh? What? No, you can't do that with an A in the class, but I never claimed that you could do that with an A in my class, right? You might be able to get a better job with an A in my class that gets you more money, and then therefore, you're able to get more chicken wings. Okay, but huh? Yeah. Okay. Anyway, and so to our two high school friends, you probably have no idea what we're talking about right now, right? Yeah. So the students have created a CS club, um, and actually affiliated it with the ACM, which is a professional society for computer science. It's called the Association for Computing Machinery. Um, anyway, they have a Discord server, and this Discord server has its built-in currency called the Gentleman Coin. And we named it that because originally it was named after something from 4chan that was a little bit more sus. Uh-huh. So, shall we say? Um, anyway, so yeah. So if you want to get on the Discord server and hang out with all these freaks, I don't know what would possess you to do that. Uh, talk to Caleb because he's the administrator for it. Anyway, okay. So let's talk about structs, right? So we have all these primitive objects, strings, floats, numbers of varying degrees of precision, whatever. Okay, but like in, well, really any programming language, you'd like to be able to define sort of compound data objects that have multiple pieces of data of potentially different types associated with them, right? So, for example, I could have like a customer's record, and that could have their first name, their last name, their address, their right. Okay, and so what all information do I need to store to do that? I'd need something like, okay, their first name would be a string, maybe their middle initial would be a character, maybe their last name would be another string, the street address would be a string, or maybe I could do it as a number and a string, right? Maybe I need the apartment number and there's another number, right? But I would need to store a whole bunch of different things, okay? And then I'd want to kind of treat the sum total of all of that data as a single object, okay? Even though it's not really a single data type, I want to treat it as if kind of as if it is, okay? Now, I might want to therefore have functions that process these things, okay? And if I want to pass these things to a function, then I'm going to have to pass pointers to them rather than um, passing them by value, okay? Because, well, as we saw with strings, can you pass a string to a function? Not directly. What really are you doing? You're passing the pointer to the string to the function, and then the function's doing stuff with that. Okay, um, and so it's going to be similar with structs. Okay, which are these compound data objects. Okay, so let me read from the book of the great book here. Okay, all right. So a structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. Okay. Structures are called records in some languages, notably Pascal, which is a language you guys have never used. Um, Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of separate entities. Okay. One traditional example of a structure is the payroll record. An employee is described by a set of attributes such as a name, address, social security number, salary, etc. Some of these in turn could themselves be structures. A name has several components, as does an address and possibly even a salary. Another example, more typical for C, comes for graphics, and this is the one that we're going to look at today, um, is a point. What would a point be, like in math class or on the screen, right? How would I address a point, or not address? Yeah, I'd have to talk about its coordinates. Okay, and maybe we could do X, Y, Z if we're doing 3D graphics, but point being, pun intended, that a two-dimensional Euclidean point, I need two coordinates to describe it, and those two coordinates could be, well, see, this sort of depends. What data type should I use for each coordinate? What do you guys think? Int or float? Okay, both are valid answers. Okay, why might we want to use a float or double for that matter? Okay, and yeah, because you could have the point 3.5 or the coordinate 3.5, for example. Okay, and that makes perfect sense in a mathematical context. Okay, why might int actually be the better choice? Choose what data type we would use if we wanted to describe points, like mathematical points. Right? So what data type would we use for each coordinate? Right? If I want to, okay, and that would be what we would use. We'd want to use integers if we were talking about pixels on a screen, for example. Okay, so you guys are looking at this projector screen. What really are you seeing? You're seeing individual pixels, and how many are there? A lot. Okay, but let's describe the number. How many are there wide? An integer, 1920 by 1080. Okay, because this is a 1080p display. Okay, good. Right. So if I wanted to be describing points in the sense of like coordinates on the screen, then using an int for each coordinate makes sense. Okay. And if I wanted to do something that's like more mathematical idea of points, then maybe using a float or a double makes more sense. Okay. So like, um, yeah. Okay. So just for the sake of example, let's just use ints. Okay. Um, and yeah, whatever. Uh, or actually, you know what? Let's use floats. Forget that. Let's do floats. Okay, so I'm going to throw in here math.h also for reasons that'll hopefully become clear in a moment. Okay, and so the first thing we need to do is we need to describe how are we going to do how are we going to describe this structure. Okay, so I'm going to come up here and I'm going to do struct, and then I need to give it a name, so let's call this a point. Okay, and then let me make sure I put the semicolons all in the right spots. Okay, and we've decided to do floats. Okay, and so now this is one thing that will catch you and nail you is that you have to put a semicolon after the curly brace when you define a thing. Okay, so what have we done here? We've defined what this point structure looks like. Okay, in sort of a generic abstract sense. So think of that like a template, if you will. Okay, have I defined a specific instance of this structure yet? No. Okay, so I could have, for example, so if I wanted to declare these, then I would say something like, um, I would say struct, let's see what I want to do. Point one equals, I think, let's see, hold on. let's say 0, 0, okay? So what does that do? Yeah, so I'm initializing a particular instance of this object, and I'm going to call it point 1, and I'm just going to initialize it to be, say, the origin for, demonstration's sake. Okay, and I could define another one. Yeah, right? This is kind of like an object in Java, or what is it? What are these things called in Python if you do something like this? Are they called objects or? Yeah, okay. Yeah, I mean, that's basically what we're doing, right? Is kind of rolling our own class object-y kind of thing. Okay. Now, the difference between, and I should stress this, that these sort of look like objects in the Java or Python sense, but we're not doing true object-oriented programming because what are things that objects also can have in addition to, the data that defines them? What else can an object have within it? A method. Okay. What is a method? It's a function that sort of only is internal to that object, not external to it. We do not have those here because we're in C, which is not an object-oriented language, right? If you want to do object-oriented stuff with this, what do you have to do? Well, Java, C++, or C Sharp, or Objective-C, which is sort of a different variant, right? So there are object-oriented sort of extensions of C, but we're looking at C, classic OG C, not C++. Okay, and that would be one of the distinctions. Yeah, okay. All right, so all a struct can do for us is be a compound data object. It's not going to have methods or any of that to go with it. Okay. All right, good. So I've defined 2 points here, and so let's just compile it to make sure that I haven't, screwed up anything. What did I do here? No, what did I do here? Okay, so this is one of the problems, by the way, of using old books like this, because this particular edition is from 1988, and sometimes things have happened. Yeah, sometimes things have changed since then. Um, um, okay, maybe I don't need this. Maybe it wants that. Damn it. Expected identifier or, well, crap. What? Well, yeah, but this throws an error also. Hmm? What? Oh, God, I'm an idiot. Yeah. I'm sorry. I remember now. Okay. This is what we want. That's right. Okay. There we go. Okay. So, right. Because, so we're declaring the existence of a particular struct of type what? Point, right? So in the same way that if I wanted to declare an integer, I can't just say x equals 5. I have to say int x equals 5, right? So point 1 equals blah, right, is declaring the existence of a point named point 1 whose initial value is 0, 0. And then I have to throw struct in front of this because these things are structs, not primitive data types. Okay, that's right. I remember now. Okay, good. Now, like I said, if you look in the book, it doesn't necessarily do it all of this stuff this way, which means when you look at an old, I need to see if there's a more recent edition of this, but that's been updated. The other thing that's really kind of annoying when you look at this stuff is it declares in this book in the 80s, what did int mean? What kind of data type was that? How many bits? It was 16. Yeah. And 32 was a long int. And then therefore, if you wanted to do 64 bits, what was that? A long, right? Okay. So when I've slipped and I've done long, it's because of that. I've been, just remembering my old programming days. What was the first language or first thing any of you guys programmed, by the way? Java? Really? You wrote code on what? Notepad? Notebook? Batch? Never heard of that. Huh. Scratch? Yeah, that's what we used in, yeah. Okay, Scratch. The first thing I programmed on was probably BASIC on my TI calculators. Okay. Or I did a robotics thing with Legos when I was a kid. And believe me, oh, you have no idea what it used to be like, right? Because this brick that like the robot can drive around, how quaint. No, it had to be tethered to the computer, right? Yeah, so anyway. Okay, so right, there we go. We've got a couple of these points described, and if I wanted to print or process with these things, well, for example, let's say I wanted to print the coordinates of the point. What would I need to do here? Can I just print 0, 0? Not directly. What do I really have to do? Yeah, I need to print its X or Y coordinate or both, whatever, right? So how do I get the X coordinate or the Y coordinate out of a specific point object? Well, I could do something like oops. Okay, so I need to pass here what to this thing? I need to pass to it a float if I want to print a specific coordinate. Okay, how do I access the coordinate, the X coordinate, out of point 1? Any ideas? Okay, not quite. Dot X. Okay, does that seem familiar? Right, from like Python or something? Right? So yeah, so I'm accessing the object called X that's within the point 1. Okay, and similarly, I could get the Y coordinate if I wanted. Right? Okay, is that okay? Yes, pardon. Well, okay, sort of. If I want both coordinates, I can't do that because what is 0.1, right? So if I just write typed 0.1, what is that really? It's a pointer, okay? The pointer to that particular instance of the structure. In the same way that if I define a string, okay, what is a string? It's an array of characters, right? So if I were to define, let me just type it out here instead of writing it on the board. Right, so if I wanted to, if I did something like my string equals, oops, sorry. Okay, and let's say, you know, I make it however many characters, right? If I do something like this, and I type just my string by itself, what does that mean? Okay, so what is, if I just say something like, okay, I need a format string, I'll finish it in a moment. Okay, if I do this, what's going to get printed? Well, it depends on what format string I use here. Okay, but so if I want to print the string, what do? I need to put an S in here, right, for print a string. Okay, okay, so something like that. Okay, but my string right there, what is that? What's getting passed to printf? The pointer to the string. Okay, so my string, now this bothers you guys because you probably think I should put an ampersand in front here. Okay, because I'm passing a memory location. Why don't I could put an ampersand there, but why don't I have to? I'm sorry? Because it's a string, and string name by itself with no extra decoration is the pointer. Okay, it can't be anything else, right? So we don't have to put the ampersand in front of my string here is honestly convenience, I think, right? Because it can't be the value of the string. That means nothing. Okay. This is, I think, what's been driving you guys crazy with pointers, right? Is that it seems inconsistent, okay? Even though it isn't. Okay. Uh, so, so 0.1 dot x is what? That's actually a number. Okay. Because what is 0.1 dot x? It's a float. In this case, its value is 0, right? But it's a data type is float. Okay. And similarly, 0.1 dot y would be 0, and 0.2 dot x would be 3, and so on, right? So whatever the numbers are. Okay, does that make sense? All right, and that's why here, when I did the print function for the x coordinate, what kind of format string did I use? I used f for float because that's what kind of thing it is. All right, so if we compile, what did I forget here? Oh, I forgot the semicolon. Oh, yeah, I hate, sorry. Okay, this is why you should never program without coffee. I do, but I'm only a quarter of the way through it. Okay. Right. Data type, then name, then yeah. Okay. All right. So let's run this thing. Okay, and that's what we get. Okay. So yes. The location of X. Yeah, it would print the location of where the x coordinate was stored. Okay, and then we could also print the location of where the y coordinate was stored. And if I threw a bunch of other coordinates in here for some strange reason, then I could see where that is. Okay, but that actually does bring up a good point. And for sake of demonstration here, let me change from the origin being zeros. Let me change this to some actual numbers. Okay. Um, and the other thing that I want to do, just for right this instant, to make what I'm about to do a little easier to explain, let me just change these back to ints, okay? And let me just do 2 points like this, and then of course that means I also have to change that to an int, okay? I'll change it back to floats in a moment, but um, perhaps, okay, but whatever. Okay, so let's just make sure that I didn't screw something up. Right, okay, and what's the only change that happened here in terms of how it looks from the printing? It doesn't have any of the decimals, right? Okay, so now the default, by the way, when you print a floating point is to have 6 places after the decimal point, even though a float can store more precision than that. The default is just to print 6 decimal places. You can have it print more if you so choose, okay? Or fewer if you so choose. That's up to you. Okay, but anyway, that's the default. So yeah, I changed the x coordinate to the number 1 here, and because I've redefined everything as ints instead of floats, okay, whatever. The only reason I redefine them in ints instead of floats is so that in a moment we're going to look at where this stuff is actually in memory and how it's stored, and it'll be easier to recognize the integers as integers than floats as floats. Okay. Okay, is that all right? Okay, so let's look at this. So let me recompile it, but I'm going to give it the debug flag, and I'm also going to statically compile it. And then we're going to pipe it through GDB. Okay, all right, and as before, I'm going to break right before the program terminates. Okay, I'm going to run it. And so everything has happened basically right up until the end of the program, right? So we've hello world did, we've printed, right? All of that's happened. And what I want to do is look at what is in memory and where, okay? Okay, good. Is that all right? Okay, so what do you notice about what's in memory? Huh? Do you guys see our structures in memory? Yeah, I do. Where are they? Yeah, they're all happen to be on the row 030. So what do we have in our first 8 memory addresses? We have 3 and 4. What do we have in our second 8 memory addresses? 1 and 2. Okay, so there's our the 2 structs actually in memory. Okay, which order did I define them in, by the way? Which one did I put first? 1, 2 or 3, 4? Okay, so it does kind of look like they're in backwards order here. Okay, whatever. Right? Uh, yeah, and that's why, because they're on the stack, and stacks go from high address to low address, so it's sort of backwards of what you might expect. Okay. Now, how many of you guys have taken data structures? Yeah, and who's not yet taken data structures? Right. Okay, so you guys will do that next semester. Um, okay. So anyway, there's our stuff in memory. Now, in this case, everything kind of fit cleanly into so each struct here took up 8 bytes, right? 4 bytes for each coordinate because I defined them as ints, the coordinates. Okay, what about if I had put strings in here also? Well, then it might have taken up more space. Okay, that's fine. So let's go in and let's add in some strings to our points, even though that's sort of silly from a mathematical point of view. Okay, so is that all right? All right, so let's go back here and let's add, let's say, actually, let's do this with a character. Okay, and then we could, when we define our point, what else do I have to do here? Oops, blast. Okay. All right, so I'm kind of thinking sort of like in math class here, right, where I might want to label a point with a letter, okay? And what would make for a good letter? Character, makes sense, right? Now I could have done a string here of just one character, okay? What's the advantage, by the way, of using a character as opposed to a string? Uh, Potentially, okay. But so let me rephrase the question. What would be the advantage of using a character as opposed to using a string that only had room for a single character? If I only let it have a single character in the string. So what's the difference between a single character and a string that is comprised of a single character?
Is string not a primitive data type, but a character is?
Yes. Okay, so there's one difference. And what do all strings need to have? What now? I couldn't hear you. They have to have a null terminator, right? So if I wanted to have a string that had a single letter in it, it would really take up 2 characters worth of data, right? The actual character and then the null terminator. Whereas a character is a single byte. There's no null terminator because, well, it's a single character. There doesn't need to be. Okay, does that kind of make sense? Yeah. Okay. Hmm? Sure.
So for integers, you can pass, you don't have to pass by,
Reference you can pass by value. Yes.
can you do that from characters as well?
Yes.
Okay.
Because they are fully contained within 8 bits.
Okay.
Right. And so what you'd really be doing, I think on modern hardware, right, is you'd be sort of pretending they're 32-bit ints and for the purposes of putting them in a register. But yeah, you can pass those by value. Because they do fit in, they're guaranteed to fit into a register, whereas a string is not. Okay. Okay. So what? So I also need to define here my labels. Okay. All right. So let's rerun this and let's say let's also do a label here. Okay. So the something like this. Okay. So let me quit here. Let me recompile it. Let's run it first. Okay. So that makes sense. Yeah. So the x coordinate is 1. The name of it is A, and yay. Okay. Good. All right. But let's look at then if we go back into GDB. Well, first off, which line do I need to break at now? 24. Oops. Okay, let's look at our memory at this point. Okay, because now what should we see for each point? What all do they have defined with them? Yeah, they've got their 2 coordinates, which are both integers, and they also have their label, which is a character, okay, which takes up, in this case, right, a single byte because characters are single bytes, right? Okay, so do we see these guys in memory? Where are they? Yeah, 0, 2, 0 for our second point, and 0, 1, 0, or sorry, 0, 3, 0 for our first point. Okay, again, they're in sort of reverse order because this is a stack, but whatever. Okay, and do we see the coordinates and the labels? All right, so the two coordinates, 1 and 2, so I'm looking at row 0, 3, 0 here. So I've got my coordinates 1 and 2, and how much data does it take to store each of those, the 1 and the 2? Hmm? The 1, how much data did it take to store that 1? 32 bits, or how many bytes? 4 bytes, okay? And that makes sense, right? Because each sort of column here of stuff is a 4-byte chunk. Yeah? Okay, so 1 took 4 bytes to store, 2 took 4 bytes to store. How much space does it take to store a single character? Okay, huh? How much space does it take to store a single character? 1 byte, okay, or 8 bits. All right? Where are those two characters located? 028 and 038. They're in these spots right here and here. Yeah? Okay. Right. Oh, come on. I don't get any laughs out of the subtle South Park references. Is it just too early for that kind of humor? You don't watch TV, but it's South Park, right? Oh, actually, this is interesting. So, how many of you guys actually do have seen some South Park? Okay, how many of you guys have seen the episode or episodes where they've got Casa Bonita, right? This Mexican restaurant. So, this is really hilarious. So, I was talking to my dad, and and we were sort of talking about what crappy jobs did everybody in the family have, their very first jobs. So he did a few things, right? I mean, he was a kid from a pretty, he was the eldest of four, blue collar family. Neither of his parents went to college. His dad was an electrician, right? Which was a good blue collar job, still is. But you're not exactly going to be living in mansions on that, especially not when you have four kids. Okay. So what did he do to make money when he was little? Well, they'd go around and find, with their little wagon and collect soda bottles back when they all came in glass, right? And then take them to the recycler for like a penny each or whatever. And then he had some spending money. And then one summer he dug trenches for a plumber. Okay, that's hard work. But then when he was in high school, he worked at, you would not believe it, he worked at Casa Bonita. Okay, in Little Rock, Arkansas. And it turns out that for a period of like 15 years, that restaurant did the most sales, like was the grossing the most money of any Mexican restaurant in the entire country, which is insane, right? And it's in Little Rock, Arkansas. And he told me the food was just terrible, by the way, right? It was just like world's worst. The cheese would come in cans that are like barrels or something. It was just awful stuff. But anyway, so the Casa Bonita that they're making fun of in South Park is the exact same chain. It was actually not a chain in the sense of like Taco Bell where there's thousands of them, but uh, where there were like 10 or something of them. And now, this is also crazy, the creators of South Park, they bought the Casa Bonita that's in Colorado. Okay, so they now own it. which I guess means they can make fun of it without getting sued because they can't really sue themselves. So yeah, huh? Yes, because and which is how they can afford to just buy Casa Bonita because they like to go there when they were kids, right, or whatever. So okay, so how much data does it require to store a single character? Well, only 1 byte. But looking at this, does it look like it only took up 1 byte? No, it really did. Okay, so what's going on with all those extra zeros um, between our 2 points? So doesn't it look like we've wasted a bunch of space? Yeah, okay, and we kind of have. We could have gotten away with spacing these more tightly. What the compiler did, though, was it tried to align things to basically fit neatly in 16-byte chunks. Okay, um, and just because it looks neater. Did it have to do it that way? No, of course not. We could have, for example, started the next number with these 3 cells and then finished with that cell. Now, would that have been a little confusing for us looking through this stack trace and trying to understand what's where? Yeah, okay. And so it was kind of nice that the compiler spaced things out for us a little bit. Okay, good. Okay, so now that I've defined these objects, sort of compound things, right? If I went back to the point where I had these as floats, okay, what might be something that we could do with points? Right, I've defined them and we just printed access the data that's in them, but what else could we do theoretically? I mean, I picked points sort of as a mathematical example, but what could you do with points? Yeah, you could add them in sort of a vector sense, okay? What else could you do? Okay, now, by the way, that brings up a good point. Could I just say 0.1 plus 0.2? Yeah, yeah, exactly. Okay, so if I wanted to add these things in sort of like vector style thing, I can't just type zero point 0.1 plus plus 0.2. I could type 0.1 dot x plus 0.1 or 0.2 dot x, right? That makes sense. But I can't just abuse the note. I can't just type plus and expect that the compiler is going to know what the hell I mean. Okay, even though you guys as humans might know what I'm up to. Okay, um, but what else could I do? Right? Could I compute the distance between these 2 points? Would that be a logical thing to do? Sure. Okay. So I could write and I would have to do this as a function, right? I would have to write a function that takes in the 2 points or their coordinates and then does the appropriate distance formula computation. Okay, so if I were to design that function, there's a couple ways that I could do it, right? How many pieces of data, okay, so for the moment, let's pretend that I've redefined x and y back to be floats, simply because if I compute the distance between 2 points, am I guaranteed to get an integer? Of course not, right? I'm probably going to get some square root of something or other, right? Okay, so fine. But if I wanted to write a function that took in 2 points and returned its distance, the distance between them as a float, okay, I'm going to have to do one of two things. I either am going to have to pass to this function 4 numbers, okay, the coordinates of each of the 2 points, or what's the other way that I could go about it? I could pass to a function 2 pointers, okay, to those objects. Okay, so Yeah, now how do I pass pointers to functions? Well, if only you guys would have had an assignment that related to that, right? Because how do you pass strings to functions? With their pointers, right? Okay, so this would be in that sense no different. It's just that we're pointing to a compound object, not to a string, right? Well, pointing to a struct instead of a string. Okay, but similar idea. Okay, so does that kind of make sense? At least for now? All right, so I'll give you guys yet another assignment. Um, and all right, so Tuesday, what are we going to start with? Assembly. We're done with C. Okay, we could spend the rest of the year on C if we wanted to, but it's time for this ship to move on to the next island. Okay. All right. See you guys on Tuesday.